right, we're looking at cyclical function models for the second day in a row, and we're still focused on our Ferris wheels. You guys are working on the same packet from yesterday, so please make sure that you have it out while we're working. All right, so yesterday we did sine, we did cosine, we looked at trig, we had circles, we had triangles, and I'm sure that it was probably difficult for some of you, and I apologize, right? Again, if you really need help, go talk to Mr. Fikes about it, and he may even have an easier way to explain it than I do. But the good news is that we actually have a formula now. So all those calculations we did by hand yesterday, we can actually have a formula for them for the future. All right, and when you guys have to work on your own, hopefully we can use the formula as often as possible. So here is your formula. All right, we have a sub t, which is just our notation. R stands for radius. Cosine 360. Okay, this little r would be the time per rotation, so rate per rotation. So in this exact problem, we'll talk about what it is. T stands for time, and then C is not circumference. Make sure you know that it is not circumference. This is actually talking about the distance of the center of the circle, center of the wheel, from the ground. Because you're going to use this formula in other problems too, all right? And they're going to be different heights. So in our situation, in our model, we would have a sub t equals our radius was 75, times negative cosine 360 divided by the rate per rotation, which we said was 30 minutes, times t, right? T is our variable that we need, and then plus 90, right? Our wheel, the center of our wheel was 90 feet off the ground. So for the rest of the calculations, or if you want to go back and work the problems from the table to just kind of make sure you're able to get them, this would be the formula you could use. So in problem 7, it says put your data in the calculator into L1 and L2. Remember that stat edit. Graph the data and the equation on your calculator. So let's start there. I went ahead and went to stat and edit and typed in the numbers from yesterday's table, right? This table, so that you wouldn't have to watch me type these numbers in. So my numbers are already in L1 and L2. I'm going to go ahead and go to y equals, and I'm going to type in the formula we just found. So 75 times negative cosine, and in cosine I'm going to use parentheses to do 360 divided by 30, close parentheses, times, what was it, t, so I'm going to use my variable, which is just x here, and then close the parentheses for the cosine. And then I got plus 90 at the end. All right, make sure that you have clicked on plot 1, because that's the only way your points from your stat edit are going to show up. So I have plot 1 highlighted for my scatter plot, and I've got my equation. So let's see what this looks like. I can hit graph. All right, there we go. It maps, it draws a line through the points that we got, and it also continues it. And you guys will notice that I kind of already did the next part of the question as well, which I should explain. It says extend the window so that you can see at least 3 revolutions of the Singapore flyer. Well, think about it. If 1 revolution was 30 minutes, and I want 3 revolutions, I would just do 3 times 30. So my window needed to go all the way to 90. So change your window on your calculator, click window, and look what I have here. I started the x minimum at 0, and I went all the way to 90 because I wanted to see those 3 rotations. The x scale, my y values, I started at 0, and I went to 175. Remember, we knew the max height of this thing was 165, so I just gave myself a little bit of extra space there. So I went to 175. All right, and that's how I can see all of my graph. I can also see 3 total rotations of my graph. Now we're going to answer some questions. So let's go ahead and look at problem number 8. How many meters off the ground is a capsule 10 minutes after it leaves the platform? Okay, well 10 minutes is kind of like your x value, right? That's your time. And so I can just find this in my calculator table. I mean, if you wanted to plug it in for t and do, all of this in your calculator, you totally could. But I just put this in my table. So I'm going to look there. So second graph, and we want to look for 10, which I can see is all the way at the bottom. So after 10 minutes, we got 127.5 meters. 127.5 meters. All right, and again, we could have just plugged in 10 for t in our formula to get this number as well. When is the first time that the capsule will reach a height of 100 meters? Okay, well, that's a y value, right? That's like the product of our formula, the result of our formula. So we're looking here for when does it hit 100 feet? Well, it looks like it hits 100 feet between 8 and 9 minutes. Okay, well, what if I wanted to be more specific? What if I wanted to know exactly when it reached a height of 100? I know it's between 8 and 9 minutes at this point, but what if I wanted to be exact? I'm going to go ahead and show you guys how to calculate that, mostly because we're going to do this in the next unit, so it wouldn't hurt to just give you a little bit of exposure here. So let's write out our formula that we know. We want it to be equal to 100, and we're going to write it out the other part here. So 75 times negative cosine of 360 over 30 times t, because we don't know t, we're looking for the time, plus 90. And I'm going to have to write small, you're going to have to write small as well. All right, let me just change this to a little bit smaller. First thing I'm going to do is get rid of the 90. Think back to algebra, right? Get rid of the constant. So we've got 10 equals 75 times negative cosine of 360 over 30 times t. Next, I'm going to get rid of the 75, right? I can divide the whole right side by 75 and the left side by 75. And this gives me, let's see, is that a nice decimal that I can just write it? Let's see, negative, not negative. 10 divided by 75. Yeah, no, I'm going to have to leave it as a fraction. So we got 10 over 75 equals negative cosine of 360 over 30 times t. All right, next I'm going to get rid of the negative. And remember, I can just do that by making this side negative and this side positive. All right, so now I'm just dealing with this cosine. So I don't know if you guys remember. If you didn't take pre-cal, then you probably haven't. Well, no, you've seen inverse cosine in geometry. All right, here's what we're going to do. We're going to go ahead and we're going to take the inverse cosine. All right, we're going to set the inverse cosine equal to this. So here's what this looks like. I'm going to take the inverse cosine of the left side, negative 10 over 75. And what that means is that the right side is no longer in the parentheses, right? Cosine is gone from the right side. And let's just say this is 12. So now, on the right side, I just have what was inside, which is 12t. And this is pretty great because my calculator can actually give me a number for that. But all we have to do to finish here is divide everything by 12. So now I've got t by itself, and it's equal to this kind of crazy looking thing, inverse cosine of negative 10 over 75 all over 12. So let's figure out what that is. Inverse cosine is right here in blue, so I got to go second cosine. And we're going to do negative 10 divided by 75. I'm going to go ahead and I'm going to press equals, and then I'm going to divide by 12. And I should get between 8 and 9. Did I do it right? Okay, good. So I get t at 8.14 minutes. That's when it hits 100 meters. Looking at the table on the calculator is way easier, but if you have to do it by hand, that's how you would do it. All right, how many complete revolutions has a Singapore flyer made after 75 minutes? I feel like this is a question that you all can answer, right? In 30 minutes, I got one. In another 30 minutes, I've had 2 rotations. I don't go all the way to 30, I just go to 15, which is right in the middle. So how many revolutions has it made? Well, it's made 1, 2, and a half. So 2.5 revolutions, so only 2 complete revolutions. Question number 11. Is a capsule moving upward or downward 47 minutes after it leaves the loading platform? Okay, well this requires, I feel like, looking at the graph, right? 47 minutes. Well, 30 minutes, it made 1 rotation. And then 47 minutes, let's see. If I go 15 minutes, I'm at the top again. So now I'm at 45 minutes, right? So only got to go 2 more minutes. It looks like I'd be going down. All right, so just kind of map it with your understanding that 1 rotation is 30 minutes, and you can understand that this would be moving down. All right, here are just some questions that you can answer in Edpuzzle. We've got the Texas Star Ferris wheel, and the equation for that looks like this. What I want you guys to do is put it into Y2 on your calculator and try and answer the questions. Which one is taller? How do you know? You know what? I'll do these ones with you. I'll give you a different question in Edpuzzle. Take a look. So we're going to type this in Y equals, and we're going to take off the scatter plot, so unclick plot 1, and we're going to clear this thing out. So 32.5 must be the radius of the Texas Ferris wheel, times negative cosine, and then we've got 360 divided by 20. Remember, that must mean that it takes 20 minutes for the Texas roller coaster to make one spin. All right, divided by 20 times x, t, and then plus 37.5. So that must mean that the center of the Texas Ferris wheel is 37.5 meters off the ground. All right, now it wanted us to compare it to the Singapore Flyer, which means I totally should not have erased that equation, which kind of sucks, but we go times negative cosine of 360 divided by 30, and then times x, and then plus 90. All right. So this is our graph. That is the Texas Flyer, and the red one is the Texas Star, and then this is the Singapore Flyer. All right, so which one is taller? All right, well, definitely Singapore Flyer. Right, because we can see how high the second one got. It got way, way, way higher than our original. All right, which one is moving faster? We'll take a look. The red one only made 3 revolutions. The blue one, the Texas one, made 1, 2, 3, 4 revolutions. So you can tell that the Texas is moving faster because you can see on the screen that it made more revolutions, right? More waves than the Singapore Flyer. Which one would you rather ride? Okay, this is totally your opinion. I would rather ride the Texas one because I don't want to sit on a wheel for 30 minutes. I don't want to sit on a wheel for any amount of time, actually. Okay, they kind of freak me out. And so I like that it's smaller and faster, but obviously that would be your opinion. Okay, guys, remember, if you have questions, you can talk to Fike, Swangon. You can ask people in the class. I'm sure somebody understands, hopefully, fingers crossed. And tomorrow and Thursday, you have an assignment to complete on your own. You're looking at just a different Ferris wheel. You're answering the same types of questions. Good luck.